everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 3 Laws of Motion. We have already discussed Newton's first law of motion. In today's class, we will be discussing mass and inertia, linear momentum and Newton's second law of motion with examples and solve many questions from exercise 3C. Are you ready for the session? Let's begin. Mass and inertia. How does inertia depend on mass? We have studied about inertia in the previous class. What is inertia? Inertia is the tendency of a body to remain in its state of rest or in the state of motion. How is inertia dependent on mass? When mass increases, inertia also increases. Okay, that is if you have two bodies of masses MA and MB. Let us say that the mass of second body MB is greater than the mass of first body MA. In that case, MB inertia will be greater in case of the second body B. Why? Because when mass increases, inertia also increases. A body with greater mass will have greater inertia. So, what is inertia we know? Yes, so if a body is at rest, we need to bring it to motion. Okay, we have two bodies of smaller mass and the other with a heavier one. Okay, so when you are applying a force to move the body, we have to apply greater force in the case of heavier body. What is the reason? In that case, inertia will be greater. Its tendency to remain in the state of rest will be greater. If the two bodies are moving, we have to stop the bodies. We have to apply more force. We have to take more effort in the case of heavier body, because in case of heavier body, the inertia will be greater. Inertia to remain in its state of motion will be greater. So, more force will have to be applied. So, what can say? Mass is a measure of inertia. When mass increases, inertia also increases. A cricket ball is more massive than a tennis ball. Here we have a cricket ball and a tennis ball. The mass of a cricket ball is 163 grams and that of a tennis ball is 58.5 grams. From this, it is clear that mass of cricket ball is greater than mass of tennis ball. In which case, inertia will be more. Now consider you have a cricket ball and tennis ball. You have to push these balls, okay, to take it from the state of rest. Okay. In which case more force is applied? More force is applied in the case of a cricket ball. Why? Because here its tendency to remain in its state of rest will be higher. Inertia will be higher. Okay. Inertia will be greater when mass is greater. Mass increases, we know inertia also increases. So, inertia is greater in case of cricket ball. Okay. So, let us consider both these balls are moving with a velocity. Okay. You have to stop these balls. In which case more force is required? It is with the case of a cricket ball. Why? Because mass is greater. When mass increases, its tendency to remain in its state of motion. When the ball is moving, it is in the state of motion. Its tendency to remain in the state of motion is higher compared to the tennis ball. Okay. So, more force is required to bring it to rest. Loaded and unloaded trolley. So, here you can see this is an empty trolley and in this trolley, there are some bottles kept. Okay. Now, you go to a supermarket, you take a trolley. It is easier to roll the trolley when it is empty. When you place many objects inside it, many masses inside it, what happens? The weight increases, the mass of the trolley increases, mass increases, inertia increases. So, its tendency to remain in its state of rest or motion also increases. Yes, so this is the reason why it is difficult to set a loaded trolley in motion than an unloaded trolley. Understood? So, if these two trolleys are moving, let's say they are moving with the same velocity, in which case is it easier to stop? By applying a smaller force, we can stop the empty trolley because here mass is less, which means inertia is less. Here what happens? The inertia is more and the difficulty or the force that to be applied to stop the trolley will be higher. Kinds of inertia and its examples. There are two kinds of inertia, inertia of rest and inertia of motion. There is another kind, inertia of direction, which is not there in your syllabus. So what is inertia of rest? Inertia of rest is the tendency of a body to remain in its state of rest. If a body is at rest, it will remain at rest unless an external force is applied to change its state of rest. We have studied Newton's first law of motion. A body remains in a state of rest or uniform motion unless an external force is applied on it. So here, this inertia of rest, the body will remain at rest. Okay. Now let us see what are the examples for inertia of rest. So here we have the first example for inertia of rest. When a train suddenly starts moving forward, the passenger standing in the compartment tends to fall backward. Same thing you will experience in case of a bus. You are standing in a bus. Suddenly when the driver starts the bus, what happens? You will fall backward. So what is the reason? Here you can see that the passenger's legs are in direct contact with the bus or train. Okay. When the driver starts the bus, what happens? The legs will start moving forward. What about the body? The lower part of the body will start moving forward, but the upper part of the body will have a tendency to remain in its state of rest. Okay. So upper part of the body will take time to move forward. Before that, what happens? The lower part is moving. Due to this reason, the person will fall down. Okay, he will have a tendency to stand backward, but the legs will move forward. Okay, so this is the first example. Second, when a hanging carpet is beaten with a stick, the dust particles starts falling out of it. You can try this, or you might have tried this before. How to remove dust particles from a carpet? This is done, right, at beating with a stick. So here what happens is, on the carpet there will be dust particles. There will be many dust particles on the carpet. So when the carpet is struck with a stick, what happens? When it is beaten, what happens? The carpet will move backward. Okay. Carpet is moving from its position. That is, the carpet comes to motion. Carpet comes to motion. What about the dust particle which sticks to the carpet? It will still remain at rest. It will have a tendency to remain at rest because of inertia of rest, and the particle will be in its own position, but the carpet will move. Now what happens? The earth will pull these dust particles down. Okay, because of earth's pull, the dust particle will fall down, and this way we can clean the carpet. Okay. So here again, this is an application of inertia of rest. Next example, on shaking or giving jerks to the branches of a tree, the fruits fall down. See this figure? All of you have done this, right? To get fruits, you shake the tree. Here actually what happens? When you shake the tree, the branches will come to motion. So branches are now in motion. Okay. What about the fruit? The fruit will have a tendency. These fruits are very massive and they are weakly attached to the branches. They are weakly attached to the tree. Now what happens? When the branches are in motion, the fruit will have a tendency to remain in its position. It will have a tendency to remain in its state of rest, continue in its state of rest due to inertia of rest. Okay. So the fruits will be at rest. Branches has started moving. Now what happens? Like the dust particles in the carpet, the earth will pull the fruit downward due to gravity, or due to earth's pull, the fruit will fall down. Okay, and you will be able to get the fruit. So you are getting fruit. Why? Because of inertia of rest. Here the phenomenon involved is inertia of rest. Fourth example, on striking the coin in the bottom of a pile of carom coins with a striker, lowest coin only moves away while the rest of the pile remains intact. So here there is a carom board. All of you have played this carom board. Okay. Now here you have a striker. With this striker, when the striker hits the coin, the lowest coin the striker hits, what happens? The lowest coin will shift to any position. Okay. What about the remaining coins? You can observe that the remaining coins will take the place of the original pile. Okay, here what happens is the first coin, that is the lowest coin, will have a tendency to move. Why? Because it is striken by the striker. Okay, and this coin will be in inertia of motion. It will start moving. What about the remaining coin? They will have a tendency to remain in its state of rest. Okay, So here the coins will have tendency to remain in the state of rest. Due to gravity, they will just move down. Okay, fifth example, when a smooth card placed over the mouth of a tumbler is flicked sharply in the horizontal direction, the card flies away but the coin kept over the card falls into the tumbler. You can try this. Take a tumbler, place a smooth cardboard over it and a coin on top of it. Okay, so with your hands, you can just strike this cardboard. What happens is the cardboard will start moving. It flies away. That is, cardboard will come to motion. What about the coin which was placed over the cardboard? It will have a tendency to remain in state of rest. Because of inertia of rest, it will try to remain in its position. Due to gravity, same thing. That is, due to Earth's pull, the coin will fall into the tumbler. Okay, this is again application of inertia of rest. Now, the second kind of inertia is inertia of motion. What is inertia of motion? If inertia of rest is a tendency of a body to remain in state of rest, then inertia of motion will be the tendency of a body to remain in state of motion. We have studied Newton's first law. A body can remain in a state of rest or uniform motion unless an external force is applied on it. Unless this external force is applied, the body will continue to be in its same speed. It will move in the same direction along a same straight line. Okay, so inertia of motion, if a body is in a state of motion, continues to be in the state of motion with the same speed in the same direction in a straight line unless an external force is applied on it to change its state. Okay, so we will be discussing the examples for inertia of motion. First example for inertia of motion, a cyclist riding along a level road does not come to rest immediately after he stops pedaling. So, have you experienced this? When you are riding a bicycle, suddenly you apply brakes, will the cycle come to rest? No, right? Only after some time the cycle will come to rest. For example, at this point, you applied brakes, but the cycle will stop only at this point. Here what is happening? When you stop pedaling, still the body is continuing its motion. So when the body was in motion, suddenly when the brakes are applied, what happens? It will have a tendency, it will have inertia, it will have an inertia of motion. Okay, it will have a tendency to continue in its state of motion. Due to this reason, it will move forward. Now what actually happens? Why does the body come to rest? Because here frictional force is acting. There is an external force acting and this external force is frictional force. Okay, Galileo has said that a body will continue in its state of rest or state of motion unless external force is applied. If there is no external force, it will continue in its state. Okay, but here you can see there is frictional force. Due to the frictional force between the tire and the road, the body will come to rest after some time. Okay, second example, when a passenger jumps out of a moving train, he falls down. We have said that a person who is sitting inside the compartment of a train or inside a bus, when suddenly the driver starts the bus, he will fall backward because of inertia of rest. Here just the opposite thing. When the train is moving, that is when the train is in motion, the person who is inside the train is also in the state of motion. Suddenly, when he jumps out of the train, what happens? His legs will come to a state of rest. Okay, you can see that the body is in motion initially when the train is moving. Legs and body, lower part and upper part of the body are in motion with the train. But suddenly when he jumps out of the train, what happens? Lower part of the body will come to a state of rest. But the upper part of the body will have a tendency to continue in its state of motion because of inertia of motion. Okay, with the train it will have a tendency to move forward. So due to this reason, he may fall. To avoid this, what can be done? You can just jump out of the train. Once you jump out of the train, for some distance you should run along the direction in which the train moves. Okay, motion of train. You can see the motion of train. You have to run in the same direction of the motion of train for some time. Only then you can prevent this falling from the train when you jump out of a train. Third example, when a running car stops suddenly, the passengers tends to lean forward. Have you experienced this? You are moving in a car. Suddenly when the car stops, initially the car is in motion, your body is in motion. Suddenly when brakes are applied and the car stops, what happens? Lower part of the body will come to rest. but the upper part of the body will have a tendency to continue in state of motion because of inertia of motion, and due to this reason you will lean forward. Okay. In order to prevent this, suddenly what happens? When you lean forward, there are chances for your head to get injured. So to prevent this, what can be done? You can wear seat belts. So why are seat belts used? Because suddenly when brakes are applied, you will have a tendency to move forward because of inertia of motion. To prevent this, when you use a seat belt, you will be maintained in your same position. Okay, it will push you backward. Clear? Next example, an athlete often runs before taking a long jump. Why is this done? You have seen that in case of a long jump or in case of a high jump, first they will be running a small distance, only then they will take the jump. Why is this done? So when you run, what happens is your body will come to a state of motion. So when your body is in a state of motion, it is easier to take the jump. Okay, have you done this before? Yes, so this is a reason why. Because of inertia of motion, it is easier for the body to take the jump. A ball thrown vertically upwards by a person in a moving train comes back to his hand. So a train is moving. There is a person inside the moving train. He is having a ball with him and he is throwing the ball up. Okay. Now what happens? The train is moving. The person is moving. What about the ball? The ball will also continue to move. So it will be going up and coming down. But do you think that the ball will fall here? No. Here what happens is, after the ball is released, after the ball is thrown, it will move along with the person and the train. So once it comes back, it will reach the person's hand. Okay, because the ball is having a tendency to remain in its state of motion. Due to this reason, the person can catch the ball again. Even though the train and the person has moved forward, the air inside the train, the ball, everything is moving forward. There is inertia of motion. Factors affecting the impact produced by a moving body. Consider a plastic ball and a tennis ball. So in this experiment, we are taking a vessel which is filled with sand, okay, wet sand. Now what you are going to do is, you are dropping the plastic ball and the tennis ball here. Okay, you know that the mass of plastic ball will anyways be less than the mass of tennis ball. Okay, when they are dropped, what happens is, here a small depression will be formed, whereas here a bigger depression will be formed. Why? Because the impact is higher in case of a tennis ball compared to the impact produced. So the force that is applied on the sand, wet sand, is greater in the case of a tennis ball compared to a plastic ball. Okay. Sometimes no depression is formed. So when mass increases, what is happening? The force is also increasing. Impact is increasing. Mass increases. The force increases. Impact increases. So one factor on which the impact produced by a moving body depends is mass. Okay, mass is the first factor. Now the second factor, we are taking a tennis ball and the tennis ball is just dropped, and the second case is tennis ball is thrown to the sand. In which case the depression will be higher? First, let us say the tennis ball has a velocity v1. In the second case, when it is thrown, the velocity is v2. Here, more force is applied. More force means more velocity. Velocity will be higher. Okay, v2 is greater than v1. So in that case, the depression produced will be higher. So the second factor on which the impact depends on is velocity. Just consider a case. Your friend is throwing a plastic ball and a tennis ball on you. In which case you will be hurt more? It is when he is using a tennis ball. Why? Because mass is higher. Okay. With the plastic ball, he is just throwing it on to you, or he is applying a greater force and throwing on to you. Which means greater force, greater velocity. The second case, you will be hurt the most. Okay. Now moving balls. Consider moving balls. In which case it is difficult? It is difficult in the case of a tennis ball. Why? Because mass is higher. Okay. Now with two different velocities, if the bodies are moving. One with the greater velocity, it is difficult to stop. Why? Because when velocity increases, the impact produced also increases. So we can say that the force needed to stop a moving body in a definite time depends on the mass of the body and its velocity. Higher mass, more force is required. Higher velocity, more force is required. Okay. Linear momentum. Consider two bottles. One bottle is filled with water and the other bottle is empty. So you are considering a table and you are making this bottles roll on the table. Okay. First you will place this empty bottle here and apply a force on the bottle. Okay. What happens? It will move till here and then come to rest. Now consider you are placing this filled bottle on the table and you are applying the same force that you applied in the previous case. Now what happens is either it will move a greater distance or it will move the greater distance and then fall down from the table. So what is the reason here? You can see that when you compare, the empty bottle's mass is less than the bottle filled with water. Okay, when mass increases, we know that the impact will also increase. Here the same force is applied, right? Even though same force is applied, the impact produces greater in case of the massive object. Okay, you are taking the same empty bottle and you are applying two different forces. Okay, when you apply, the same bottle is used, which means mass is the same. Okay, when you apply first a smaller force, it will move up to here. When you are applying a greater force, what happens is the velocity will increase. When force increases, velocity will increases and it can move a greater distance and fall out of the table. Okay, so we can say that the two factors are mass and velocity, and these two factors product when taken, you will get the quantity called linear momentum. Linear momentum is equal to mass into velocity. Okay, mass into velocity. So linear momentum of a body is the product of its mass and velocity, and momentum is a characteristic property of an object, of a moving object. Okay, they represent momentum with letter P. We know mass is represented with small letter m, and so momentum is represented with small letter p. Momentum and linear momentum normally are the same. Linear momentum in this chapter will be just using the word momentum there. Okay, so P is equal to mass m into velocity v. Okay, so here we know that mass is a scalar quantity. What about velocity? Velocity has both magnitude and direction. So when you take the product of mass and velocity, one is a scalar quantity and the other one is a vector quantity. Then what about momentum? Momentum will also be a vector quantity. It has both magnitude and direction. Clear? What is the unit of linear momentum? So we have linear momentum is equal to mass into velocity. P is equal to m into v. Then what is the unit of momentum? Unit of momentum will be equal to unit of mass unit of velocity into unit of velocity. What is the unit of mass? SI unit of mass is kilogram. Unit of velocity meter per second. So the unit of momentum is SI unit of momentum is kilogram meter per second. This is a derived unit. We have studied about derived unit in the first chapter. What about the CGS unit? CGS unit means in case of SI unit, you will be taking length in meters, mass in kilogram and time in seconds. Okay, this is the case of SI unit. Now what about CGS unit? In case of CGS unit, you will be taking the length in centimeter, mass in grams, time in second. Okay, so here unit of mass should be taken as grams in CGS units. So CGS unit, gram, unit of velocity will be centimeter per second. Okay, so CGS unit for momentum is gram centimeter per second. Got it? So we'll take two examples. to understand linear momentum better. Take the case of a bullet. You know that bullet is a very small object. So how can a very small object hurt you so badly? Have you ever imagined this? So you can see that when this very small object like a bullet is fired out of a gun, what happens? Its velocity is increasing. Its velocity is high. So when velocity increases, we know that momentum also increases. Okay, momentum P is equal to mass into velocity. Here mass will remain the same, but the velocity is increasing, therefore momentum is also increasing. And due to this reason, the impact produced, the force is higher, and then it will cause a greater harm. Take another case. There is a car and there is a lorry. Which is massive? We know that the mass of lorry is greater than mass of car. In which case the momentum will be higher. Let's say that both of these vehicles are moving with the same velocity. So what is the momentum of lorry? Momentum of lorry will be equal to mass of lorry into velocity. Okay, and momentum of car is equal to mass of car into velocity. So velocity is same, but when mass increases, the momentum will increase. So let's take a case. If a person gets hit with a car and a lorry, in which case the accident will be more. Accident will have a greater impact when it is with a lorry moving with the same velocity compared to a car. Why? Because mass is higher. Okay. Now take the case of two cars. Two cars are moving with different velocities. So velocity of the second car is greater than the velocity of first car. Okay. So again there is an accident caused, in which case impact will be more. We know that momentum is equal to mass into velocity. Velocity increases, momentum also increases. Same car, which means mass is the same, but velocity is higher, the accident cost will be higher because of greater momentum. Understood? Now we'll take another case. Okay, we said that the momentum depends on mass and velocity. We have mass of lorry greater than mass of car. Okay, but let's say the momentum are different. Okay, velocity of car is greater than velocity of lorry, we are considering. Okay, mass of lorry is greater than mass of car and velocity of car is greater than velocity of lorry. In this case, where the momentum will be higher, we'll have to calculate the momentum, right? So momentum of lorry will be mass of lorry into velocity of lorry. Okay. Momentum of car will be equal to mass of car into velocity of car. Here we are saying that the velocities are also different. Velocity of car is greater than velocity of lorry. Now what happens? We have to compare the momentum. Okay. Sometimes the momentum will be equal. Momentum of lorry and momentum of car will be equal because here one quantity is higher compared to the other quantity, right? So we may get equal values. Sometimes the momentum of lorry will be less than the momentum of car, or the momentum of lorry is greater than momentum of car. All these chances are possible. So where the momentum is higher, the impact or the accident cost will be higher. Change in momentum. Let us consider a case. Initially, a car is moving with some velocity u. Okay. After some time, the car is accelerated. Its velocity becomes v. We know that momentum depends on mass and velocity. So here we have initial velocity and final velocity. Then we will be having two types of momentum. One is initial momentum and the other is final momentum. So initial momentum will be equal to, we'll take it as some P1 will be equal to mass into initial velocity u. Final momentum will be equal to mass into final velocity v. We have said that momentum depends on mass and velocity. there is a change in velocity which we can represent as delta V. What does delta mean? So this is how a delta is represented, and delta means a small change. Okay, a small change is represented with the Greek letter delta. Okay, so delta V will be equal to V minus U, change in velocity. When velocity there is a change, there will be change in momentum as well. So this change in momentum is represented by delta P. And this delta P, for a body, we know that the mass will be same. Okay, mass into delta V, or you can write this as delta mv. Change in momentum depends on change in mass and change in velocity. If there is a change in mass, then there will be delta m as well. Okay, so how do you get the change in momentum? Initial momentum and final momentum is considered. Subtracting the initial momentum from final momentum, you will be getting the change in momentum, which is equal to m delta v. Let us consider a case where mass m is equal to 1000 kilogram. Initially, the velocity is 30 km per hour and the final velocity is 50 km per hour. How to find the change in momentum? We have change in momentum, delta P is equal to m into delta V, which is m into V minus U, change in velocity. First, we need to find the change in velocity. We'll get delta V. Delta V is equal to 50 minus 30. That is, what is 50 minus 30? You get 20. Okay. So, here mass is 1000 into 20. Okay. So, mass is in kilogram and the velocity is in kilometer per hour. So, kilometer per hour will be the unit in this case. Okay. So, this is how you can find the change in momentum. First, find the change in velocity and multiplying with the mass, you will get change in momentum. Rate of change of momentum. So, we know how to find change of momentum. Now, how to find rate of change of momentum? Consider a force is applied on a body which is moving initially with the velocity. Initial velocity u meter per second. So, when this force is applied, what happens? Its velocity will increase. Then final velocity is v meter per second. So, by applying a force in a time t, what happens? There is a change in velocity. Okay. Let's say the body is of mass m. Now, what is the change in velocity? Change in velocity is equal to v minus u. This is the change in velocity. Now, what is rate of change of velocity? What is rate? With respect to time, what change is happening? We know that rate of change of displacement is velocity. Velocity is equal to displacement by time, which means with respect to time, what changes happen to the displacement? Acceleration is equal to velocity by time. With respect to time, what changes happening to the velocity is acceleration. So, rate of change of momentum means with respect to time, what changes happening to the momentum? That is rate of change of momentum. So, we got change in velocity. Now, what is the change in momentum? We have momentum is equal to mass into velocity. So, here change in momentum will be equal to final momentum minus initial momentum. So, we need to find what is final momentum and initial momentum. So, how to get final momentum and initial momentum? Final momentum will be mass into final velocity. Mass into final velocity v. Okay. Initial momentum will be mass into initial velocity u. M is common, m into v minus u, or change in velocity into mass will give you change in momentum. Now, to find rate of change of momentum. Rate of change of momentum will be equal to m into v minus u divided by t. T is the time. Okay. Or this can be written as m into V minus U divided by T. What is V minus U by T? What is V minus U by T? Acceleration. So, you will be getting mass into acceleration. Okay. So, rate of change of momentum is equal to mass into acceleration. So, when a force is applied, the velocity changes, there is change in momentum, and the rate of change of momentum when found will be we will be getting mass into acceleration. When a force acts on a body, the rate of change in momentum of body is equal to the product of mass of the body and acceleration produced in it due to that force, provided that the mass of the body remains constant. So, we have a simple alternate method. When a force is applied, we said there is a change in momentum. So, change in momentum is delta P. With respect to time, when there is a change in momentum, we represent as delta P by delta T, which is rate of change of momentum. What is delta P? Delta P is mass into change in velocity by change in time delta T. Or we can write this as m into delta V divided by delta T. What is delta V by delta T? Delta V is change in velocity. Delta T is change in time. So, change in velocity by change in time. What do we get? It is acceleration. So, we get acceleration. Okay. So, mass into acceleration is delta P by delta T. Rate of change of momentum is equal to mass into acceleration. It is a product of mass and acceleration. Newton's second law of motion. Here you can find a ball. Let's say the mass of ball is m. When a force is applied on the ball, what happens? The ball will start moving. Why is it happening? Because it is gaining a velocity. It is getting accelerated. Let's say initially when a force is applied, the acceleration A1 is equal to 5 meter per second square. Now, different forces applied, the acceleration A2 is equal to 10 meter per second square. Here it is clear that the acceleration A2 is greater than A1. Okay, 10 meter per second square is greater than 5 meter per second square. Now, in which case more force should be applied? To increase the velocity. Okay, when you apply a small force, what happens? The velocity increase will be small. But when a large force is applied, it can move a greater distance, which means the velocity gain will be greater, the acceleration will be greater. What do you understand from this? When the acceleration is greater, the acceleration will be greater only when the force applied on the ball is greater, which means F2 will be greater than F1. Okay, to produce more acceleration, more force should be applied. From this, we can conclude that acceleration and force are directly proportional. When force increases, acceleration increases for a body of mass m. Okay, mass is not changing. So, when you plot a graph taking force along the x-axis and acceleration along the y-axis, you will be getting a straight line inclined to the x-axis. Okay, this is how you will be getting, and here mass is a constant for a body of constant mass. Okay, the acceleration produced in a body of given mass is directly proportional to the force applied on it. Okay, so one factor on which force depends is acceleration of the body. Now consider two balls, a cricket ball and a tennis ball. We know that the mass of a cricket ball is higher compared to the mass of a tennis ball. Okay, let's say in both these cases, acceleration produced should be 5 meter per second square. Same acceleration is to be produced, which means the force applied should be different. In which case more force should be applied? Most force should be applied in the case of the ball with greater mass, which means force and mass are directly proportional. When mass increases, force also increases. Okay, so here the mass of cricket ball is higher than the mass of tennis ball, which means the force that is to be applied in case of cricket ball will be greater than force that is to be applied in the case of a tennis ball. When you plot a graph with mass taken along the x-axis and force along the y-axis, you will be getting a straight line that is inclined to the x-axis, okay, for a constant acceleration. Constant acceleration. When mass increases, force also increases. the force needed to produce a given acceleration in a body is directly proportional to the mass of the body. Okay. Mathematical expression of Newton's second law. So, from the first case, we have acceleration and force are directly proportional. From the second case, we have mass and force are directly proportional. So, this and this on comparing, we get force depends on mass, force is directly proportional to mass, and force is directly proportional to acceleration. Okay. To remove this proportionality, we can introduce a constant. So, F is equal to K into MA, where K is a constant of proportional. For a convenience, we will take K is equal to 1, then F is equal to M into A. Okay. Force is equal to mass into acceleration, or force is the product of mass and acceleration. Okay. Now, first graph we had force taken along the x-axis, acceleration taken along the y-axis. When you take the slope of this graph, what do we get? When you take the slope, here acceleration, here force. So, you will be getting A by F. Okay. And this A by F will be equal to 1 by M. The slope of a acceleration along y-axis and force along x-axis graph will be giving you reciprocal of mass. Okay. Second graph, we had mass along the x-axis and force along the y-axis. When you take the slope of this graph, here you have force, here you have mass, you will be getting acceleration is equal to force by mass. When you take the slope, you will be getting acceleration. Here when you take the slope, you will be getting the reciprocal of mass. Okay. So, we have the expression force is equal to mass into acceleration, which is the expression for force, which is a mathematical expression for Newton's second law of motion. Now, how is mass and acceleration related? We know that force is directly proportional to mass, acceleration is directly proportional to force. What about mass and acceleration? When you take mass and acceleration, they are inversely proportional. Okay. When mass increases, let's say for a constant force, force should be a constant. Okay. If force should be a constant, let's take the case of 1 kilogram mass and 2 kilogram mass. Okay. Force should take the same value F. Clear? So, let's say some 10 newtons. 10 is the force. Okay. Newton is unit of force, we all know that. So, 10 Newton is the force. We have a body of mass 1 kilogram. We don't know its acceleration. Let's say A1. So, then what is the value of A1? A1 will be equal to 10 by 1, which is equal to 10 meter per second square. Okay. Next, another second body that is of 2 kilogram mass. Force is the same. Force applied is 10 Newton. 2 kilogram into acceleration A2. Then A2 will be equal to 10 by 2, which is 5 meter per second square. So, here you will understand that M1 is less than M2, but A1 is greater than A2. A1 is equal to 10 meter per second square and A2 is equal to 5 meter per second square. Which is greater? A1 is greater. Okay, what does it mean? This means that mass when increases, acceleration decreases. Mass and acceleration are inversely proportional. Okay, so when you plot a graph with mass taken along the x-axis and acceleration taken along the y-axis, this is how it is. Okay, this is an inverse graph. Here force is a constant. Constant force, this is how you will be having mass on x-axis, acceleration on y-axis graph. Clear? From this we can say that force is a product of mass and acceleration. When you are given with mass and acceleration, you can easily calculate what force is. Just we have to take the product of the mass and acceleration. F is equal to M into A. C.G.S and S.I unit of force. We have force is equal to mass into acceleration. F is equal to m into A. So, unit of force will be unit of mass into unit of acceleration. That is, when unit of mass is, to get the SI unit, mass unit will be kilogram, and acceleration will be meter per second square. So, unit of force will be kilogram meter per second square. There is another unit which is capital letter N, Newton. Okay, we write it as NEWTON. Remember, the starting letter should be small letter N and not capital N. Okay, we have studied the rules in the first chapter. Now, the C.G.S unit is when length is in centimeters, mass is in grams and time is in seconds. So, here mass into acceleration, gram into acceleration, centimeter per second square. Okay, so the unit of force will in C.G.S unit will be gram into centimeter per second square. Okay, this gram centimeter per second square is dyne. This is a unit. Okay, so 1 Newton is a force which when acts on a body of mass 1 kg produces an acceleration of 1 meter per second square. So 1 Newton, when do you get 1 Newton? 1 Newton will be equal to 1 kilogram into 1 meter per second square. Then what about 1 dyne? 1 dyne is a force which when acts on a body of mass 1 gram produces an acceleration of 1 centimeter per second square. Okay, so 1 dyne is equal to 1 gram into 1 centimeter per second square. Okay, now what is the relation between Newton and dyne? Let's see. We have 1 Newton is equal to 1 kilogram into 1 meter per second square. What is 1 kilogram? Convert kilograms to grams. 1 kilogram is equal to 1000 grams. So, 1 Newton is equal to 1000 grams into 1 meter is 100 centimeter. 100 centimeter per second square. How many zeros? 1, 2, 3, 4, 5. So, 10 raised to 5 gram centimeter per second square is 1 Newton, or 1 Newton is equal to 10 raised to 5 dyne. Okay, so this is a relation between the two units of force. One is the SI unit and C.G.S units. 1 Newton is equal to 10 raised to 5 dyne. Let us take an example. How much force is required to produce an acceleration of 2 meter per second square in a body of mass 0.8 kg? We have to find the force. We have force is equal to mass into acceleration. Here we are given that mass m is equal to 0.8 kilogram. Also acceleration is given. Acceleration A is equal to 2 meter per second square. So here mass and acceleration both are in their SI units. So no conversion is necessary. Now how to find force? Force is equal to mass into acceleration, which is equal to 0.8 into 2. Okay, that is 1.6. What is the unit? Here kilogram meter per second square. We know the unit of force. What is the unit of force? Unit of force is Newton. So this is equal to 1.6 Newton. Okay, so 1.6 Newton force is required to produce an acceleration of 2 meter per second in a body of mass 0.8 kilogram. Okay, second example, a ball of mass 10 gram is moving with a velocity of 50 meter per second. On applying a constant force on ball for 2 seconds, it acquires a velocity of 70 meter per second. Calculate the initial momentum of ball, the final momentum of ball, the rate of change of momentum, acceleration of ball and the magnitude of force applied. First we have to find the initial momentum of ball. In the question we are given the mass m is equal to 10 grams. So here we have to convert this 10 grams into kilograms, that is the SI unit. Okay, we know that 1 gram is equal to 1 kilogram is equal to 1000 grams. Then 1 gram is equal to 1 by 1000 kilogram. Okay, what about 10 grams then? 10 gram will be equal to 10 into 1 by 1000, that is 10 by 1000 kilogram, which is equal to, cancelling zeros, 0.01 kilogram. So, mass is 0.01 kilogram. Next, initial velocity is given, u is equal to 50 meter per second. Final velocity is 70 meter per second. And we are given time t is equal to 2 seconds. Okay. So, first part of the question, we have to find the initial momentum. Initial momentum. Initial momentum will be equal to, what is momentum? Momentum is the product of mass and velocity. To get initial momentum, product of mass and initial velocity, m into u. Put the values, m is equal to 0.01, u is equal to 50, which is equal to, this becomes 0.1 into 5 or 0.5 unit of momentum, kilogram meter per second, 0.5 kilogram meter per second. Okay. Now, the second one, the final momentum of the ball. What is the final momentum? Final momentum will be equal to mass into final velocity, 0.01 into 70, which is equal to 0.7 kilogram meter per second. Now, third part of the question, we have to find the rate of change of momentum. How to find rate of change of momentum? What is rate of change? Rate of change means divided by, change in momentum divided by time interval. Okay. In how much time this change is happening? So, change in momentum will be mv minus mu. Final momentum minus initial momentum in time t. Okay. We know what mv is. What is the final momentum? Final momentum is 0.7. What about initial momentum? Initial momentum is 0.5. Time taken 2 seconds. Divided by 2. 0.7 minus 0.5 is 0.2. Divided by 2, which is equal to 0.1. Okay. Kilogram meter per second square. Kilogram meter per second square. Okay. Next, we have to find the acceleration of ball. Fourth one, acceleration. What is acceleration? Acceleration is equal to final velocity minus initial velocity divided by time. Here, 70 minus 50 divided by 2, which is equal to 20 by 2 equal to 10 meter per second square. 10 meter per second square is the acceleration. Next, we have to find the magnitude of force applied. What is magnitude of force? How to find magnitude of force? We have force F is equal to m into A. M into A. Here, mass is 0.01 into acceleration is 10. Therefore, you will be getting 0.1 Newton. 0.1 Newton is the force. Clear? Now, let us solve numericals from exercise 3C. Question 1 of exercise 3C. A body of mass 5 kg is moving with velocity 2 meter per second. Calculate the linear momentum. Here, mass is given. Mass m is equal to 5 kilogram. Velocity v is given 2 meter per second. How to find linear momentum? Linear momentum represented by letter P is equal to mass into velocity. That is m into v equal to 5 into 2, that is 10 kilogram meter per second. Kilogram meter per second is the unit of linear momentum. Question 3 of exercise 3C. A force of 15 Newton acts on a body of mass 2 kg. Calculate acceleration produced. Here we are given the force. Force F is equal to 15 Newton. Mass of the body is given. Mass M is equal to 2 kilogram. We have to find the acceleration. Okay. Force is equal to mass into acceleration. Then what is acceleration? Acceleration is force divided by mass, which is equal to 15 divided by 2, that is 7.5 meter per second square. So here the unit will be meter per second square only when the force is given in Newton and mass is in kilogram. If the mass is given in grams, you have to first convert that mass into kilograms. Next, question 5 of exercise 3C. Calculate the magnitude of force which when applied on a body of mass 0.5 kilogram produces an acceleration of 5 meter per second square. Here we are given the mass of the body and acceleration. We have to find the force. Okay. Mass is equal to, mass M is equal to 0.5 kilogram. Then acceleration A is equal to 5 meter per second square. Okay. We need to find the force. Force F is equal to mass into acceleration, which is 0.5 into 5 equal to 2.5 Newton. So, the force is 2.5 Newtons. Clear? That's all for today. In today's class, we have discussed how inertia is dependent on mass, linear momentum, rate of change of linear momentum and Newton's second law of motion. We have arrived at an expression for force. We have also solved questions from exercise 3C. Hope you all have enjoyed the session. I'll be back in the next session. Until then, stay tuned to Learno Hub. Learno Hub free hai, par best hai. Thank you.